Last week, we talked all about domain and range. So you guys are very good at identifying domain as always the X, range is always the Y. Then we also talked about the words discrete and continuous. A discrete function is one that is made of just ordered pairs, just the dots, where continuous is a continuous line from one dot to the next dot. So today we're going to talk a little bit more about discrete and continuous, but it's very easy. So it's the same idea, but now we're just tying some real life application, which will actually make it a little bit easier to understand the difference between a discrete graph and a continuous graph. So in our first example here, it says cell phone cases are on sale for the new iPhone. Each case costs $4 plus a $1 protection plan. This is modeled by the equation C of x equals 4x plus 1. So before we start figuring out our table and our graph, what I want you to do is write the letter x. So earlier we had said that x is always the domain. It's a number from the x-axis. But another word for x is the word input. What input is means that we would put the number into the equation for x. So x is my input, where my y is range, y graphs on the y-axis, but in this situation, y is our output. So what that means is that in this situation, the number on the outside, whatever that is called the output. That's the y value, and this is the x value, okay? So in this situation, it says each cell phone case costs $4 plus a $1 protection plan. This is modeled by this equation. So if we look on this right side here, it asks what my x and my c of x represent. So let me change this window just a little bit. All right, much better. So the x in this situation represents the cell phone cases, because it says each case is $4. So each case is $4. So x is my cell phone case. So that's my input. My x value is always the input. Cell phone case. Each cell phone case is $4 plus the $1 protection plan. So that means that my output, or my y value, is the total cost. So in this one, we have the cost of my cell phone. C of x, just like f of x, g of x, h of x, it's just a fancy way of saying y. So don't let it confuse you. It's just the same as y. Just the high school way to say the letter y is to use it as function of x. So what we have here, the first question is, one cell phone case will cost how many dollars? So remember, x is cell phone, y is cost. So one cell phone case costs how many dollars? So let's figure that out. So if I go to my equation, it says 4 per case. My first x value is a 1 plus $1. So that means that 4 times 1 is 4 plus 1 is 5. Okay, so for one cell phone case, it's going to cost me $5. So now let's plug in a number 2. So I keep my function. My x is the cell phone cases. So when I buy 2 cases, $4 times 2 is 8 plus 1 is 9. Next. Now I want to know how much it costs to buy 3 cell phone cases. $4 for each case times 3 cases plus $1 is 13. Next, 4 cases of 4 times 4 plus 1 is the number $17. So now that I have these points, I'm going to graph them on this coordinate plane right here. But because I see that I don't have 17 boxes going up, I'm going to take my y values and count by 2. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Big enough? And then my y values are fine. I can count those by ones. X values are small, so it's 1, 2, 3, 4, 5. I don't even have to go past that. So what this table created is ordered pairs. When the x value is 1, the y value is 5. So on my graph, here's 1. 5 would be like right there, between the 4 and the 6. Okay, so there's my first ordered pair. The next one says that when x is 2, the y value is 9. Okay, so when x is 2, here's 2, the y value is 9, which is going to be right about there. Okay, next one. It says when the x value is 3, the y value is 13. So that ordered pair, 3, 13 is approximately right there. And then finally, when the x value is 4, the y value is 17, which is approximately right there. Okay, so now what you learned in middle school was that whenever we have some dots, we graph them and then we connect the dots. But in this case, we don't connect the dots. We have to think about what's going on here. So what we graphed are my cell phone cases. I bought 1 case, I bought 2 cases, 3 cases, 4 cases. So is it possible to have 1.5 cell phone cases? If I drew a line here, it means it would have to make sense to have a cell phone case for every single number on this graph. But I'm not going to go to the store and ask for 1.5 cell phone cases. That's ridiculous. So this is called a discrete function because in this situation, I can't connect my dots. It doesn't make sense to have half of a cell phone case or 3/4 of a cell phone case. Any number between 1 and 2, 1, 1.5, 1 3/4. No, I can't buy a fraction of a cell phone case. I can only buy them in whole numbers. So in this situation, this is not a connected line graph. This is not something that's called continuous. This graph is called discrete. So if we look at the bottom half of this page, it says, the definition of a discrete function is that they are separate, distinct points. Ask yourself if fractions or decimals are okay. So if we were talking about cell phone cases, and I think, can I have a fraction of a cell phone case? So if you went to the store and you're like, hi, I would like 2.5 cell phone cases, they're going to look at you like you're crazy because that is not a thing. We cannot have fractions in this scenario, so therefore it is called discrete. It means it's just specific dots, specific ordered pairs. We can't have a fraction of a cell phone case, so that's why it's called a discrete function. So if we looked at our graph, when we write our domain and range, we have to write it like a discrete domain and range. What that means is that we have to list the x values from the table. We had 1 cell phone case, 2 cell phone cases, 3 cell phone cases, 4 cell phone cases, and we could keep going on with the number of cell phone cases. I can't use this symbol from like 1 to 4 because this symbol means it's every single number between 1 and 4. No, I'm not going to buy 1.1 cell phone, 1.2 cell phones, 1.3. That's crazy. So I can't write it like this. So I have to write it as just the whole numbers, just the ordered pairs we had. We had 1 case, we can buy 2 cases, we can buy 3 cases. My range is my y's. That was the output. I plugged in my numbers and out came my y values. So the first cost was $5 for a cell phone case, $9 for the next one, 13, 17, ... And the cost would keep going up forever. So this is how we would write a discrete function. Discrete means it's just the list of my whole numbers in this case, because I can only buy cell phone cases in whole numbers. I could buy 1, I could buy 2, I could buy 3, I could buy 4, but I can't buy 1.5, 1 3/4, etc. So that's how it works to be discrete. Discrete means I can only have specific numbers, no fractions and no decimals in this situation. So now let's go ahead and flip over to the back. Okay, so on the back it says, your height from age 0 to 5 years old can be modeled by this equation. Okay, so if we said before, h of x, that means that h, that's my height. So my total height is 2 times x. The only other variable here is age. So my x value is my age. So my height is my total height, how tall I was, compared to my age is modeled by this equation. So my x represents my age, and my h of x, or my y, represents my height. So I'm going to make a table. The x's are the age. If I go back to the situation, it says from 0 to 5 years old, okay? 0, 1, 2, 3, 4. I could keep going to 5. We'll go to 5, that's fine. There we go. From 0 to 5 years old, so this is my height. So in this situation, I am now going to take my x values and plug them in to the x value in the equation. So I input my x's, the x is the input. So I have a 2 times 0. 2 times 0 equals 0. So obviously when I'm 0 years old, my height is 0. Next one, 2 times the next x value is a 1. 2 times 1 is the number 2. Next one, 2 times my age is 2 years old. 2 times 2 is the number 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. So now that I have a graph, which I created by figuring out that the x's was my age and the y is my total height. Now I'm going to take my ordered pairs and put them on this graph. So I start with 0, 0. 1, 2. 2, 4. 3, 6. 4, 8. 5, 10. I messed something up. I missed a number. Sorry, guys. There we go. 2, 1, 2. 2, 4. 3, 6. Here we go. 4, 8. 5, 10. Perfect. Okay, so there are my ordered pairs. I took this table of ordered pairs and I put it on the graph. So now, I need to ask myself, in a continuous graph, it means that every point has a meaning. So this one here is talking about age. So if I'm talking about age, is it okay to have fractions? We're talking about age and we're talking about the height. So if we're talking about our age, is it okay to have fractions in this situation? So are you ever 1.5 years old? Are you ever 1 3/4 years old? I'm going to label this to make it easier to see what's going on here. That's my age. And this is my height. So if I'm looking at this, absolutely, you are 1.5 years old, 1 3/4 years old, 2 years old, 2.5, 2 3/4. Yes, it is okay to have fractions when we're talking about your age. So therefore, this is a continuous graph, which means that it would continue all the way through the graph. We're going to say that this pattern would continue forever. So as you're getting older, your height is continuing to go. So in this situation, since it is a continuous graph, my range and my domain. So what we said last class is when we have domain of continuous, it means we put it between two signs. My smallest x value, hold on one second, we're going to go just from this here, just as what it said. Okay, so my smallest x value is right here. It's a 0. So I start at 0. And then it says the biggest x value that we have. Since it said from 0 to 5, my biggest x value was a 5. So this here is a graph of every number between 0 and 5 on the x-axis. Remember, domain is left to right. So that's how I write my domain. So now my range is my y values. Go back to domain. The left side was closed circle, right side is a closed circle. So my domain would include the signs. So now with range. So my range is my y's. My range is the bottom of the graph to the top of the graph. The lowest y value in this graph is a 0. The highest y value on this graph is a 10. They are closed circles, so I'm going to close off the symbol. So this is called a continuous function because every point on the line has meaning. If we were talking about age, we can absolutely have fractions of age. And height, absolutely, we can have fractions for height. So it's a continuous graph, which we write the domain and range, just like we had here. So now let's go ahead and flip to the next page. Okay. So now you guys are going to try this exact thing on your own. I'm going to start you off with the first one, and then you can try the next ones. It says, Jimmy bought a tree and is measuring its height as it grows. Its height is modeled by the function f of x equals 3x plus 2, where x is the number of years he has had the tree, and f of x is the tree's height in feet. So remember, x is first, y, or f of x, is second. So it says, create a table for the tree's height over the first 10 years. Okay, so we're going to start at year, we'll start at year 0, it's fine. So we have my year 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so those are my x's. I got that because it said years, and it said that its years are between 0 and 10. So my first 10 years for this tree. So now to get the y value, I have to take this x and plug it into the equation for x. So 3 times 0 plus 2. 3 times 0 plus 2 is 2. And then I plug in the next number. 3 times 1, the next x value is a 1, plus 2. 3 times 1 is 3, plus 2 is 5. And then I continue. This is a really ugly 2. 3 times 2 is 6, plus 2 is 8. 3 times 3 is 9, plus 2 is 11. 3 times 4 is 12, plus 2 is 14. 3 times 5 is 15, plus 2 is 17. 3 times 6 is 18, plus 2 is 20. 3 times 7 is 21, plus 2 is 23. 3 times 8 is 24, plus 2 is 26. 3 times 9 is 27, plus 2 is 29. 3 times 10 is 30, plus 2 is 32. Okay, so I took my x values, I plugged them in for x, and then I got my y values. So the question is, what does the domain represent? Well, we know that domain is x, and it said the x was talking about years. Then it says, what does the range represent? Well, range is y, and the y was talking about the height. Is this graph going to be continuous or discrete? So what this question is asking is, if we're talking about years of a tree, I'm going to write down the word fractions, question mark. If we're measuring a tree, are fractions okay? Let's see. Can I have a tree that is 1 year old? Yes. Can I have a tree that's 1.5 years old? Yes. Can I have a tree that's 1 3/4 years old? Absolutely. So fractions are okay. So what we said on the last page is that if we can have fractions and decimals in both the x and the y, then that's going to make it a continuous graph. It means it's going to graph every number from my start to my finish. It says create a graph for the first 10 years. Okay, so we'll graph it. The x's are good. We'll count by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. We have plenty of x values. So my x is the years. And then the y's get pretty big, so we need to figure out a number that we can count by to fit 32 on my y value. So we can count, let's see, 3, 6, 9, 12, 15, 18, 21, 24. Yeah, that's plenty. Okay, so my y values, I'm going to count by 3s, so that way they'll all fit. Okay, and I would keep going all the way up until we got to 32. If my graph was zoomed in, it would make it a little bit easier for us to see where that is. So now we need to graph these ordered pairs. When we have a table that's horizontal like this, don't forget that we have x's and we have y's. So my first ordered pair is a 0 with a 2. So 0, 2 is going to be like right here. Then I have a 1, 5. Then I have a 2, 8. I'm going to continue through my graph all the way to 10. There we go. So those are my years and this height of the tree. So those were in years, and this is the height. So what we had said earlier is that because this is continuous, it means that on my graph, we can have fractions. So I can connect these ordered pairs. It means that every single spot on the line has a meaning. 1.5 years, it's about this tall. 2.5 years, 2 3/4, 3, 3.5, 3 3/4. It's called continuous because every spot on the line makes sense. I have years, I have height, fractions are okay, so therefore it is continuous. So on the last piece of this, it says what is the domain and what is the range. So if I look at what we have here, well, let's take a look. So since it is continuous, continuous domain is going to look like this. So my smallest x value was a 0. My biggest x value was a 10. It included both sides. So x was the number of years old my tree was. Range is the y. The smallest y value was a 2. The biggest y value was a 32. Because there was a line in my graph, meaning fractions, decimals are okay. Every spot on the line has its own purpose. It has a point. That means that we had to write our domain and our range like we would for a continuous graph. My domain is every number between x and 10, 0 and 10. My range is every number between 2 and 32. So go ahead and try the next one. Try a couple of these, and then we are done with discrete and continuous.